Hey there, fellow student programmers. Today, I'm thrilled to introduce you to a fascinating piece of code, a complex ReactJS chat app integrated with Firebase. But hold on, let me break it down for you in simpler terms. Imagine you're building a chat application, something like WhatsApp or Facebook Messenger. You want users to be able to sign in, send messages, and see real-time updates without having to refresh the page constantly. That's where this code comes into play. By using ReactJS, a popular JavaScript library for building user interfaces, along with Firebase, a powerful platform for building web and mobile applications, we've crafted a seamless chat experience. Users can sign in with their Google accounts, exchange messages in real time, and enjoy a smooth, responsive interface. But why is this code useful? Well, think about it. In today's connected world, communication is key. Whether it's collaborating on a project, staying in touch with friends and family, or engaging with customers, having a reliable chat application can make all the difference. Plus, as aspiring programmers, understanding how to integrate technologies like ReactJS and Firebase opens up a world of possibilities for future projects and career opportunities. Now, without further ado, let's dive into the code and see how it all comes together. All right, let's break down this complex ReactJS chat app integrated with Firebase step by step. First off, we have our app.js file, which serves as the entry point for our application. Here, we initialize Firebase and set up authentication and routing logic. Moving on, within our app component, we define a state variable user using React's useStateHook. This variable will hold information about the currently signed in user. We then use the useEffectHook to listen for changes in the user's authentication state. If a user is signed in, we set the user state to the authenticated user object. Otherwise, it remains null. Next up, we have the sign-in and sign-out functions, which handle user authentication using Firebase's authentication services. When a user clicks the sign-in button, the sign-in function is triggered, initiating the authentication process via Google's OAuth provider. Conversely, the sign-out function is called when the user clicks the sign-out button, logging the user out of the application. Moving on to the chatroom.js file, this is where the main chat functionality resides. Within the chatroom component, we again use React's useStateHook to define state variables for storing messages and the user's input for sending new messages. We then utilize the useEffectHook to subscribe to real-time updates from Firebase's Firestore database. We query the messages collection, ordering them by timestamp and limiting the result to the last 100 messages. Whenever a new message is added to the collection, the onSnapshot listener is triggered, updating the message's state with the latest data. The unsubscribe function typically refers to the method used to stop listening for real-time updates from a Firestore database collection or document. This method is essential for cleaning up resources and avoiding memory leaks when the component unmounts or when we no longer need to receive updates. The onSnapshot method, which we use to subscribe to real-time updates, returns a function that can be called to unsubscribe from further updates. This function acts as a cleanup mechanism, allowing us to detach the listener and stop receiving updates from the Firestore database. In our chat application, it's crucial to unsubscribe from real-time updates when the chatroom component is unmounted or when the user signs out. This ensures that we don't continue to consume resources or receive updates unnecessarily, improving the efficiency and performance of our application. To implement the unsubscribe function in our code, we typically store the unsubscribe function returned by the onSnapshot method in a variable within the useEffectHook. Then, in the cleanup function returned by useEffect, we call this unsubscribe function to detach the listener. By unsubscribing from real-time updates when they're no longer needed, we optimize resource usage and prevent potential memory leaks. This adherence to best practices ensures that our application remains efficient and responsive, providing a better user experience overall. In summary, the unsubscribe function in Firebase is used to stop listening for real-time updates from Firestore, helping us manage resources effectively and maintain the performance of our application. It's an essential part of the lifecycle management of real-time listeners in Firebase-powered applications. Additionally, we define a handleSendMessage function that is called when the user submits a new message. This function adds the message to the Firestore database, including details such as the message text, sender's ID, display name, and profile photo URL. This ensures that the chat remains synchronized across all clients in real time, Let's delve deeper into how this function works and its significance in our application. Firstly, within the handle send message function, we perform a basic validation to ensure that the message input is not empty. If the message is empty or contains only white space, we return early without sending the message to the database. This helps maintain data integrity and prevents sending invalid messages. Next, assuming the message is valid, we use the DB object, which represents our Firestore database instance, to access the messages collection. We call the add method on the messages collection to add a new document containing the message data. The message data typically includes the following fields: text, the content of the message; created at, a timestamp indicating when the message was sent. We use firebase.firestore field value. Server timestamp, to automatically generate a server-side timestamp, ensuring consistency across clients and preventing issues related to time zone differences. UID, the unique identifier of the user who sent the message. This helps associate messages with their respective senders. Display name, the display name of the user who sent the message. This information is used to identify the sender in the chat interface. Photo URL, the URL of the profile photo of the user who sent the message. This is optional, but can enhance the visual experience of the chat interface by displaying user avatars. Once we've constructed the message object with the necessary fields, we pass it to the add method, which asynchronously adds the document to the messages collection in the Firestore database. After successfully adding the message to the database, we clear the new message state variable, resetting the input field in the chat interface to prepare for the user to enter another message. Overall, the handle send message function enables users to interact with the chat interface by sending messages in real time. By leveraging Firebase's Firestore database, we ensure that messages are stored securely and synchronized across all clients, providing a seamless chatting experience for users. In summary, the handle send message function is a crucial part of our chat application, facilitating the sending of messages and ensuring the real-time synchronization of chat data across clients. Lastly, we have the chat message JS component, which renders individual chat messages. Depending on whether the message was sent by the current user or another user, it applies different styles to distinguish between sent and received messages. The component also displays the sender's name and profile picture alongside the message content. In summary, this code aims to create a fully functional chat application using ReactJS and Firebase. It allows users to sign in, exchange messages in real time, and enjoy a seamless chatting experience. Through the integration of Firebase's authentication and Firestore database services, we ensure that the application is secure, responsive, and scalable. In conclusion, understanding how to build a complex ReactJS chat app integrated with Firebase opens up a multitude of possibilities for larger-scale applications. This code serves as a solid foundation that can be extended and adapted to meet the specific requirements of various projects. One of the key benefits of this code is its extensibility. By modularizing components and separating concerns, developers can easily add new features or modify existing ones without affecting other parts of the application. This promotes code reusability, making it efficient to leverage existing functionalities in different contexts. Moreover, this code embraces important development principles such as component-based architecture, which promotes code organization and maintainability. By encapsulating logic within individual components, developers can focus on building small, reusable pieces of code that can be composed to create larger, more complex applications. In terms of efficiency, the integration of Firebase's real-time database ensures that the chat application remains responsive and scalable, even as the number of users and messages grows. Firebase's authentication services also provide a secure and seamless user experience, reducing the need for developers to implement complex authentication logic from scratch. Overall, this code exemplifies best practices in modern JavaScript development, leveraging the power of ReactJS and Firebase to create a feature-rich chat application. By mastering these technologies and principles, student programmers can not only build impressive projects, but also develop valuable skills that are in high demand in the industry. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding and keep exploring.